dimension, thus the ST2 orbital of C1 and C3 are perpendicular to one another. Hence, two of the elements lie on the same equilibrium.
I'm very hungry. Hang on. Okay, come. Let's start doing the practical first. You're gonna go in next Monday. This one here. Yeah. What are we trying to find? Okay, quick questions. So see whether the definitions are intact. Specific capacity. What they're not asking you to find. They are not asking you to find the heat capacity. They're asking you to find the specific heat capacity. So it's a. So what's the units of specific heat capacity? Huh? What else? Yeah, joules per kg per degree Celsius. Right. Write down the units. Like write down the units there. So at least you know. Yeah. No, you asking me. You're supposed to write it your own. No. Joules per kg degree Celsius. Per degree Celsius. Okay. So the degree Celsius is also at the bottom. Right. Denominator. Okay. Okay. Next one. Okay. That right shown. Okay. So I'm going to look at the answer. Troublesome, huh? You see this? It's 0.5. Okay? That means you have to write it down to 0.5 of the degree Celsius. So you can write it as 30.0. Doesn't have to be 0.5, huh? But you cannot write 29.1. You cannot write 29.2. You can either write 29.5 or 29.0 or 30.0, but just not anything in between. Because the smallest division is 1 and a reading will be half of the smallest division. Can? For what? For thermometer only. Right? Everything else is a measurement, right? Measurement means 2 readings, right? Okay. So, how about the measuring cylinder? Sorry, what's the measuring cylinder? Beaker, is it? What they ask you to use to find the volume? This is troublesome. Hang on. You know what? I'll open 2 instances of it.
Yeah, but there's no
I have it side by side now. Collect 50 cm cube. Just write 50 cm cube. But the measuring cylinder should be 0.5. Again, 0.5. Yeah. Because measuring cylinder is also taking a reading also. Right? You fill it up, you only take 1 reading only, right? Yeah.
For things when you take 2 readings, you do not take the small fraction.
No, for things that you take 2 readings, you do not take half of it. You take the full smallest. Yeah.
Whatever's on the
Correct. Yeah. Wow, this one first question already both is half. Okay. Calculate the mass. Okay, given these numbers, write down the numbers. What is it again? Let's write 50.0. Hey, where's the pen? Fine. Oh shoot, what is it doing all the way then? cm, right? Cube. Then temperature is what? 29.0 degrees Celsius. These are all numbers, right? Okay, what's the mass of the yeah? What's the mass of the tap water? 50 grams, right? But should you write 50.0 grams or 50 grams? 50.0 grams. Right, 50.0 grams.
Go through the smallest test and everything. Like
So this one here is a bit strange because this one here is a multiplication, right? So you're taking a 2SF multiplied by a 3SF, right? So technically speaking, this is supposed to be 2SF. It's supposed to be 50 grams, not 0.0 grams.
so you take the smallest one.
You're supposed to, but the answer says you take 50 to 1 dp. Yeah. I think the reason is because the precision is given in this density already. So it's a bit worrying now. Right. So confusing. Which one should you do?
Apparently, as long as it's 2 to 3S, something hard.
I also agree with that.
So like anything just 2 to 3S. And then like reducing the operation.
Yeah. It's I think okay. I will just tell you this, okay? Let's not focus on that too much. Okay? There will be students that will write 50 grams. I believe they will get the correct answer anyway.
Yeah.
Yeah, they'll get the correct answer. Right? I think that's what your teacher said, right?
Yeah.
Don't know whether your teacher told you that. But from what I know, is in the last few years, even this is also okay.
No, the whole physics is hard.
Yeah, like in the last few years now. In the last few years, right? The SEAB, because don't forget who decides who will get the marks and the grades, right? At the end of the day, it's SEAB side. SEAB will be looking through your answers and judging whether or not you should get the marks. They look through everything. For teachers to openly say that it's okay if it's 2 or 3 SF, right? Okay, means that it's not a big deal. Yeah, it's really not a big deal. Yeah. Okay, hang on, let's go on to the next one.
So any calculation can be done as 2 to 3S. Any calculation can basically be done.
I will still try to follow the rules, right? I'll still try to follow the rules, the least one still. But for this particular question, because they gave me 1.0 grams, I would just give them in 0.0 grams. Yeah, I'll still give it to them in 0.0 grams. I mean, I won't leave it to 2 SF. I will do it as in it's a 1 dp. Yeah, not because of the SF. This one here. So they're saying that from the side benches, take the slaughtered mass, which is cold, right? So I'm pretty sure that there's some cold slaughtered mass as well. Bring it back to the bench. Okay, so the cold temperature, whoa, that is cold. 2.0, right? So you're supposed to record the temperature of the container containing the thing. So you go to the site there, you must go and measure temperature. Temperature is 2.0 degrees Celsius. Right, as an example. Okay? Then they ask you to insert it in and then find the final temperature. Okay? And in the example here, the final temperature is given as 25 degrees Celsius. So you start off with what temperature again? 29.5, 29.0. We start at 29.0. Cold temperature is 2.0 degrees Celsius. Final temperature, according to this one, is 25.0. So we just do 25.0. Okay, 25.0. Okay, and then ask you find the difference. So this one minus that one, this one minus that one. Okay, so since it's a minus, you follow the dp. All of them are all down to 1 dp, so you just give them to the same dp as well, right? 0.5, right, of a difference. So yeah. Okay. Take note when you're doing this kind of experiment, right? Just make sure that your thermometer is inside swirling for a while already before you take it out, right? Don't just like that. Then you kanchong, then you never wait, right? Then you quickly go, and then you think that that's the temperature. It's not, Okay, so you have to give it some time.
You know, like, do we have to put the retort stand? We just hold it.
You can hold it, Why do you have to put it on a retort stand? Yeah, no, yeah, why? You're not supposed to stir it though.
We just hold it. Just make sure.
So let's say you have a something like this and there's a heater, right? You have to make sure that the bulb is somewhere in the middle, not near the bottom. Because if it's near the bottom, it actually might be very hot. So you just kind of like somewhere in the middle here like this. Right? Then you're supposed to use a glass rod to stir it, lah, right? But who does that? Just like that a bit also, so a bit, no? Okay? You're supposed to calculate the specific capacity of brass, yeah, using all the values that you have been given. Right? So there you go. So temperature drop of tap water, temperature rise of the slotted mass, right? Can you work out the temperature rise and temperature drop? What are they? 4 and 23 degrees Celsius, right? 4 and 23 degrees Celsius, good. Right? And then after that, they ask you to, yeah, to calculate this one out. So you need to have, what do you need to have? You need to have the mass of water, right? Do you have the mass of water?
Yeah.
Oh, we calculated the mass of water here, right? 50 grams, 50.0 grams. And the brass is 100 grams, right? So what you notice is they didn't use SI here. Doesn't matter, okay? Everything down here all non-SI because grams are degrees Celsius. They're all not SI units, right? Doesn't matter. You get the answer can already, right? But make sure your units are correct. Go and calculate the specific capacity given all the numbers that we've talked about just now.
Do our working things have the same SF?
Huh?
Like, do the working things have the same SF as the final answer? Doesn't matter.
You just work out an answer first. You just see what's the answer you get first. Then we decide whether or not we want it to leave it to 2SF or 3SF later. I have to eat my dinner. Very hungry. You can answer? What's your raw unrounded answer? 0.365. So in their answer, they also leave it to 3SF. So down here, they request for a correct SF. But why 3 though? Why not 2SF, right? Because even the value they given also is 4.2 joules, right? That's an interesting question. Because down here right now, the mark scheme did say to the correct SF. So what is the correct SF? Shouldn't it be 2SF? I felt that it should be 2SF, right? Sometimes some schools also a bit inconsistent also. But this Gan Eng Seng, Gan Eng Seng is quite good. Strange, huh? I myself also, I have no idea what is it supposed to be, honestly.
Is it true that you can minus 9 marks for
No.
Huh? Really?
Yeah.
Like throughout.
Oh no lah. They mean the tables and all that. Yes, of course ah. But for this kind of question, this kind of things, it's only a one general mark. Let me think first. 0.365 is it?
I put 0.37.
Hey, all your answers all out range eh? But all out range eh? Because within range is 0.39 to 0.43 eh?
Yeah, our temperature.
Oh, is it? How big difference? 0.5 a degree, then the whole thing is so different. Wow, that's damn messed up, man. Let me think about this. I'll put it as 2SF. Because the least amount of SF is. Okay, I'll put it as 2SF, and then I'll justify. I'll say that, oh, the least SF in the raw values is 2.
How do we justify?
Yeah.
Write it down.
Yeah, write it down. I'll write it down. Yeah. Because the least SF given in the provided in data is 2, right? You see, this one is 4.2, right? This 2, what? I'll give it as 2. Yeah. Okay, planning, come. We're done with that. So let's do planning first. Read the planning one quick. Then we work it out. What in the world? Okay. Okay lah, can lah. It's just a matter of like what to plot, right? So your job is to find G, right? You have to do whatever you can to find G. MW is the mass of water. T warm is the temperature of the warm water. T final is the final temperature. Okay. But isn't it pretty much the same as before? Yeah, it is, right? It is pretty much the same as before. So I'm a bit concerned right now because what are you changing then? You see, right? G is supposed to be a constant, right?
Yeah.
So which means the heat capacity of that means the heat capacity of the brass and the water, I mean, they're gonna be constant. The mass of the brass is constant. What it means is that, hey, the initial temperature of the warm water must be constant too. You can't change that. If you change the warm water temperature, then you will lose marks here. So you have to read this thing and infer that G is supposed to be constant. It has to be constant, so you have to fix it. So what are you allowed to change then? So you can't change this, you can't change this, you can't change this, you can't change this, you can't change this. And in fact, if you can't change T1, we can't change the T1 outside here either. So there are these two things you can change, right? But T final is a dependent variable. It's a dependent variable, right? It's a dependent variable. So the only thing that you can change is just the mass of water, the amount of water that you have. You understand what I'm saying? Okay. So what are the quantities that you need to keep constant? List down the whole thing. Right, mass of brass, initial temperature of water. Oh, actually that's about it lah. Because the heat capacity of water and the heat capacity of brass will be the constant anyway, alright? Yeah. So that's all. Okay. You could also change the initial temperature of the brass. No, sorry, you can keep that constant, but it's not in here, right? Initial temperature of the brass, the T code is not inside here. Yeah. But it doesn't matter, I think. Yeah.
Why do you have to keep mass and
Because it's constant. Like G is a constant. And in order for it to be constant, you have to make sure that it's constant. Yeah. Okay? Okay? So I would suggest the initial temperature of the brass to be constant as well. I would say that you want it to be constant as well. Right? That's actually quite important. Right? But as to why, doesn't matter. Right? I think it's to keep it like a control temperature, make sure that it's consistent. Right? So what would you change and what would you like measure? So you would change the mass of water, right? Okay, you change the mass of water. How would you change the mass of water? So you would change different amounts of water, right? So measure volume, calculate mass of tap water. So pause water, fully submerged mass, right? Measure T final accurately, right? So repeat for 5 or more sets of different volumes of or mass of water. Okay? So you would use different volumes. But how would you describe how you change the mass of water? Vary the amount of water by increasing the number of times you use the measuring cylinder. That means 50 cm cube at first, right? Then 50, 100, 200, 250, 300 lah, right? Are you supposed to list out the values? Do you remember if your teacher said that you have to list out the values or you're not supposed to list out the values?
You said you can list out example values.
List out the values. Okay, go ahead and list out the values. All right. Since you know the values, right? You knew the original value, just list it out. So you list out 50, 100, 150, 200, 250, 300, 6 values in total. Okay? All right. Then after that, detailed description of how you will perform the investigation. So I think pretty much you have to talk about the same things as you did just now. Collect the mass, submerge the mass in the water. Do you have to stir? Did they say stir? They didn't say stir? Okay, they didn't mention about stirring also, so don't stir. Right, and then measure the final temperature, is it? Until the temperature reaches a constant, is it? What's the instructions? What was the previous instructions? What did they say? Measure and record the lowest temperature. The lowest temperature. Okay? The lowest temperature that the water can go. Okay? Okay. Alright. Alright. But okay, so the table, you will measure, you will what? Record the what? Volume and then the mass, right? Record the volume, the mass, and then the final temperature, T final. Right? You will measure the T final here like this. Hey, but here's the thing, very important. What do you plot? A statement of the graph that you will plot. Do you plot? I mean, obviously you have to plot 1 over mass of water and 1 over final temperature, right? But what do you put on the y-axis? Right? T final, 1 over T final, 1 over T final, and this is 1 over mass of water, right? Do you know why is it important not to swap it around? The y-axis is supposed to be the dependent variable. This one is supposed to be the independent. Right? So that's why you cannot swap it around. So with that statement, then you really more or less home run already. Okay? Plot T final against 1 over MW. Right? Gradient can be calculated from the, heat capacity can be calculated from the gradient. But you have to be explicit and say how to get it from the gradient, because the gradient doesn't represent the heat capacity of brass. The gradient represents G. So you have to show them how to get G. How to get the heat capacity of brass. Okay? There we go. Okay. Let's look at the next one. Electricity. Oh boy. Will circuits be set up for you? Or do you have to set it up everything by yourself? You have to set everything by yourself, right? Make sure you know how to connect your voltmeter, your ammeter, and your batteries. You basically just connect on the plus side everywhere to the plus side of the power supply. You understand what I'm saying? Yeah. Right?
Just connect it.
Yeah. Okay. Just make sure that you connect the plus side to all the plus sides of the battery. Okay. What's the You're supposed to record everything, ah? 2 lamps in series. It's a 2dp, so your analog is it 2dp? Are your ammeters and voltmeters in 2 decimal places?
Yes.
These are analog, right? Not digital, right? Are they digital?
No.
Analog, ah? Can be 2dp, man? Very fine lines, is it? Very fine divisions, ah?
No.
Mm-hmm. Mm-hmm.
You can tell that 2dp.
Okay.
Voltmeter is like 0.0.
Okay, good. Yeah, you're right. Yeah. I think that's the case. Yeah. Why?
Do you think how small is the
No.
For voltmeter,
You do?
it's like
Wait, but I mean you do it because that will be the
plus 1 reading.
yeah.
Oh, is that why there's like 2dp?
Yeah. Wait, let me see first. No, they never say voltmeter is 0 to 3 only. But it's half of the smallest division. Okay. Because it's just a reading also. Okay. Ammeter also, that means. Is it?
No, the thing is, it's like 0. It's like a ruler.
Okay.
You can tell the
That means half also lah. That means ammeter also half of the smallest division. So that means they're all 0.5, right? Like the play safe lah, you see the value, right? That's 1.70 lor. Right, 0.40. Yeah. Different setups will give you different values on Okay. Oh, look at the current though. They give weird numbers. They have weird numbers. But you're right, the voltages, look at the voltages. The voltages are in 0.05s.
Yeah, for current it's 0, 0.2, 0.4, 0.6, all the way to 0.
Oh, only up to 0.8. Okay, low currents. So 0.2 to 0.4. How many divisions are there?
It's like divided. I think it's 10. Maybe it's 0.8.
So 0.2 divided by 20 divisions. Each one is 0.01. Yeah. So each one is 0.01. So you can measure down to 0.01. That's why you can go out the 0.46, 0.17, 0.20. Okay? Okay. Right, so at least you know now. Okay. Then find the resistance. So these are the values inside here. So I think we don't have to worry about that. Using data with a single lamp, determine the resistor X. Three SF. Oh yeah, 3SF. Why is it not 2SF? You divide by 0.26, right? I wonder what the schools.
Maybe it's 2 and 3.
Hmm?
If like you don't follow the SM rule, you can put it as 2 or 3 SM.
Hmm.
It says resistance is 3 SM.
Yeah, down here, right? No, not on the question paper, lah, right? Yeah. So why are we not using 2SF here? Because all these current values are all 2SF, right? And these are all 3SF. So why is this 3SFs? I think it's for more detail. so worrying, this thing. But you see, in general, right, a lot of their questions here are all living in 3SF one. Like no matter what, they just do it in 3SF. They just don't care one. 3SF, 3SF, that's some of the previous questions also 3SF. Now here also resistance X also 3SF. Okay lah. But this is where you can lose marks if you don't calculate it to 3SF. Like what you say, right? Yeah, this one here. If you put it to 2SF, would you have lost marks? It's always very annoying why they don't have any clear indication of it. No? I will put it as 3SF because it gives a bit more detail. If I put it as 2SF, right, then all my values here will be like 9.0, 13, 16, and 4. I mean 3.8. SF rule, right? Yeah. They're never very clear about this though.
So just the calculation.
I think as long as it makes sense, they can cut marks.
Yeah, what does it mean by not making sense, right? I would love to tell you that there's a hard and fast rule to this lah, but year after year I see all the different prelim papers, all of them all different one. So it is very annoying. Okay, now for this one here, we just take it as 3SF first. Alright. Yeah, I'll take it as 3SF first. But it's definitely not 4 lah, right? Yeah. And I would think that if it's a circuit question, I would like to give a bit more detail, so I will give it as 3SF. Okay, this one suggests why Rx is not equal to the true resistance of resistor X. Alright, so for 2E and 2F, I suppose if you have to lose those marks, I guess you can lose those marks. Because here's the thing, your calculations, right, in the previous ones assumes the connecting wires have no resistance, right, or the batteries have no resistance. So therefore, since they have resistance, right, yeah, there you go, right. So the connecting wires, right, there's internal resistance in the battery. Okay, so it's not going to be the same. But then, okay, so if you can answer E, right, I don't expect you to know how to answer F also, right? How do you make sure that Rx is closer to that of resistor, the true resistance, right? For F, right? Huh? What? E is there's internal resistance of the battery as well as resistance of the wire. So whatever you calculate here, right, you completely ignore that resistance. You like assume that it was 0, right? Yeah. So in reality, there is that resistance, right? And therefore, the calculation for the resistance is not accurate. Okay, for this one here, now I know how to answer this because this one, I mean, I teach my A-level students. But, honestly, if you have to let go of this one, just let go of it, it's fine, right? I mean, there's some practical marks that you can't possibly get on, right? So, but I mean, if you learn it now, then you gain another point of experience. Then at least you know that if they do come up with this question again, you know what to do. So the answer to this question is, so you basically want the current to be as low as possible. In the circuit, you want the current to be as low as possible, because when the current is high, right, then a lot of energy is wasted to the surroundings due to resistance and heat loss, right? So the battery loses, the wires also loses. So all the values that you calculate for the resistance Rx, right, will be wrong, especially even more wrong if your current in the circuit is high. So what you want to do is you want to make sure the current is very low. Okay, but how do you make current in a circuit low? Huh? How do you make sure that it's low? So you can lower the voltage of the system. Yes, that's actually one way. Or you can use more resistors, more external resistors in the circuit. Yeah. You can actually, yeah. So, oh no, goodness. Oh, to minimize resistance. Oh no, this is completely wrong. It's the other what the totally what why I don't. Okay, that means they treat it a bit differently. Lah. So you see, right, when you minimize resistance, right, what happens is the current will start flowing, right? Then everything will heat up, right? Then internal resistance of battery, right, will waste more energy. So this is a bit of disconnect. Lah. I suppose if I dumb it down to the O level side, then yeah, okay, right? If your E here is talking about the resistance of the wires, then you say use thicker wires for lower resistance. Okay? If your E here is talking about the internal resistance of the battery, then you say you add on another resistor to make the current lower. Yeah. Yeah. What is there anything important that you seen there? It's just experiments, right? Yeah. It's pretty much the same as this one. Does that give an answer key? Don't look at it too much. Yeah. No answer key very hard one. You can read it just to anticipate what kind of nonsense they can ask you. Do they have answers on it? Yeah, then be very careful. I'd rather you just look at all the list of things that I have. Yeah. Okay, this one. Hmm? What? Hmm?
Light energy.
Hmm?
Light energy.
No. So it's about. So you see, right? I think the key phrase here is filament lamp. Filament lamp in electricity should trigger something like, what's the thing that you would trigger?
It's not on.
Yeah, there you go. So then you have to consider how it behaves when current starts to flow in the filament lamp. What does it do? Yeah, it heats up.
Oh yeah.
So your filament lamp heats up, right? So the first thing that you should realize that it heats up. As it heats up, what happens then?
Oh, resistance.
Yeah, go. Yeah. Right. So why does the ammeter decrease, right? Because as the filament heats up, its resistance increases, right? So overall resistance of the circuit increases, and therefore, right, the ammeter reading will decrease. This will be a very difficult practical to do. This one here, Mahi, this one here will be a very difficult practical to do. So you're supposed to do a beaker and water. So you're supposed to trace the outline of the beaker onto the piece of paper first. This one is very hard because, right, your beaker, the bottom is rounded, right? So when you put your pencil in, right, like this, right, it's very hard to get exactly to the edge of it. So, but you must try lah, no matter what. Okay. Then the next difficult part is you need to mark out exactly the point there, right? You need to draw a tangent and the normal to the tangent. So that's the tough part. Drawing a tangent to a circle is difficult. But if you know how to do it, then okay lah. But if you don't know, then it's tough lah. Right? You have to move your ruler until you hit a certain point. When you are doing this, try to use your pencil lightly first. Don't go and draw too hard. Because if let's say you make a mistake, right, then it's very hard to erase. Right, so try to draw it a bit lightly first, then draw this one, then draw the two there. Huh? Beaker? No, I don't know. I don't think so. But I know glass block has. Yeah, glass block has. Yeah. So what exactly are you supposed to do here? You're supposed to draw on a piece of paper, right? You're supposed to put these two pins, right? Here like this. You're supposed to draw the line first, then you put the two pins on it. Okay. There is a requirement, but I don't know why a lot of teachers don't say it out. You have to remember that these two pins must be more than 5 cm apart. It cannot be less than 5 cm apart. But there's no instruction to do so. You have to do it out of your own accord. That means you must know that it must be more than 5 cm apart. Okay? Yeah. But I think the most important thing is this. What are you supposed to do on this side then? I think this is the part where I think you get a bit confused also.
Yeah.
Like, what are you supposed to do here on this side? Okay? So on this side, which is basically like the this one glass block, right? Okay? So you got two pins, right? You got two pins here like here.
You must put it like on this side.
So you must put it on this side, right?
So that height.
Yeah. Wait, hang on. You all say that, right? But there's a couple of tricks to doing this. So what you imagine is that you are looking in this direction, okay?
Yeah.
You can see the two pins, right? Correct or not? But you have to close one eye.
Yeah.
You cannot open both eyes.
Then like,
Because if you open both eyes, right, you can never align it on. And you must make sure that it's the same eye that you're using for repeated experiments. Because you see this, right? Okay, everyone do this. Two fingers in front of you, close one eye first, alright? And then you align your two fingers so that you cannot see the finger at the back, okay? Then you switch eye.
Oh.
Right?
Yeah.
Then suddenly you can see two fingers. Correct or not? You understand this? So don't go and switch your eye, So by hook or by crook, right? You got to make sure that you have to keep one eye closed. I've got a lot of questions from students over the years. They say, what if you cannot keep one eye closed? Then I'm sorry, you go and use tape. Tape. Alright. I also agree that yes, you might not have the hand-eye coordination for it. Really? Okay? So tape more, just use tape. But what about my eyebrows? Yeah. Then what you do is you put one pin, right? Using that one eye, right? You put one pin to block, right? The first two pins, right? So you have two fingers now. So you practice it on your own, like this. So you make sure that you can only see this finger in front. Then you put one pin in front of the one there, like that. So you can only see this one in front of you. 3 pins now, right? 3 pins now, Then you put one more pin like this. Okay? Yeah. So that means you put this one already, then put this one. Then you're supposed to remove everything and then you're supposed to draw the lines. Okay? So for this kind of experiment, right, you read the instructions very carefully. Do it step by step. Trace the outline. Remove the beaker. Mark a point. Draw a tangent at point A. Draw perpendicular. Label it as NM. NM is the normal. Using a protractor, draw a line. Measure 70 degrees. Measure the angle of incidence, which is, this is damn dumb. Why can't you just ask me to measure the angle between the line and the normal? So this one, the angle starting off is 20 degrees, right? Starting off angle is 20 degrees. Okay, so 70, 90, 20. But anyway, just follow instructions. Follow instructions, so you have no choice, right? So that means you at some point, right, you need to label 70 somewhere. You need to label XAB 70. XAB is 70. If you don't label 70, maybe the teacher not happy, they take away marks from you. Right? Not teacher lah, examiners. Right? The invigilators, they're not happy, right? They'll take away marks from you. Okay? So you make sure you do all that. Hey, so you see, right, if you look at the instructions, right, they don't want you to conduct it yet, no? They want you to continue to draw 80, 90, 100, 110. That means you have to draw everything out first. Why? Why cry? No, this is a good practical because I just need to follow instructions. But that's all I have to do. It's just like making an IKEA cupboard. Right? Just follow instructions. You know what's the problem? I always skip this. I always skip instructions. That's not I read the thing. I know, I know what's gonna happen next. I know what's gonna happen next, right? Then afterwards, hey shit, how come the shelf looks a bit off? Oh, because I forgot to reverse it the other way around. So my lesson learned is follow instructions. Sometimes you just have to just follow, okay? So do all this first, then you pour the water, okay? Then you do the optical pins. Now, then using only one eye, and using the same eye, okay? Well, one thing you have to say is using the same eye. So the distance between P1 and P2 should be about 3 cm. Then you do 3 cm, okay? Yeah, but usually it's 5 cm. This is a bit strange. The person who said this one is a bit strange. No, really, a bit not the same. But okay, so I had a discussion with some teachers, MOE teachers, and they guarantee that these kind of mark schemes, right? They've gone through many rounds of approvals already before they are okay with it, and which means that these are good for O levels ones. So the prelim papers are actually very good for helping you in the O levels. Yeah. Okay. They ask you to plot, no issues. Describe. Okay, can. Sin I, sin R. You expect to see a plot, say sin I against sin R. You expect to see a proportional graph, right? A straight line. Okay, so there you go. Suggest that n is the refractive index of water in the beakers. State two conditions for this statement to be true. Wow, two conditions for this to be true. Wow. Wait, this kind of stupid question, very annoying one. I might skip, next one. State one key source of error and explain how it affects the value calculated in P. What's one key source of error that you can think of?
You can't write like what if 126 happens.
Oh, wait. There's a few standard key sources of errors, all right? Yeah. Isn't there? So for optics, right? For like optics, there's a few standard key sources errors. Do you all not have that? I mean, I don't have it, but I think someone has it. Do you have it?
Yeah.
Okay, anyway, so the thing is this, the pins are not infinitely thin.
Yeah.
Right. Hey, where is it?
Optic.
So where are you getting, so does the print not have any tips and tricks or not?
It's vertical.
What? Pins aren't vertical.
I don't know, my teacher was talking about this in class.
Key sources of error.
I was just
Okay, anyway, so for optics, right, there's a few key sources you can think of. Okay, usually the go-to, my one, right, is the pins are not infinitely thin. But what does it affect? What, 2 marks there? So if your pins are not infinitely thin, the holes they make on the paper are quite big. And therefore, the line drawn, but you see, right, which line are you talking about? Are you talking about your incident ray or your emergent ray? No, it will be the emergent ray. You know why? Because as per instruction, right?
Oh yeah.
You draw the incident ray first, so there shouldn't be any error on the pins for that. Or actually, okay, like your pencil is not infinitely thin, no. The line drawn is not infinitely thin. So when you place the pins on the line, right, they may be slightly misaligned. Okay, for in this case, I would just say that, okay, it's not infinitely thin. So when I draw the emergent ray, right, the gradient of the emergent ray may be affected, right? May not be accurate or may be affected. Okay, I say affected lah because I don't know how it's affected, right? This will lead to what? An error in what? Angle of refraction, right? Lead to an angle of refraction, and
It
No. It might be bigger, it might be smaller. Depends, all right? Yeah. So the gradient might go haywire, right? So the n value will not be accurate. That's it. Yeah. So you're supposed to link the reasoning all the way to whatever they want. So it's like, how does it affect the refractive index? You need to talk about all the steps.
So the pins are not. Also, don't say if it increases the way through this. Just like say it will be a.
Yeah. In this instance, yes, one more time.
So it's because the pins are not infinitely thin.
Mm-hmm.
Okay. Could you done more?
Wait, Hmm? How come they never use that anymore? Oh, they don't use it anymore already, man. Strange. Okay, but these are all correct. These are all correct. Okay, so another one of the more famous ones will be this one. Right? Tracing it, right, is like, it's very difficult to place the beaker back in the exact position. Right? So you have to say that, oh, okay. So this affects the calculations of angle of emergence, calculations of sine A over sine R. Okay, something like that.
The whole thing is mentioned.
Oh, sorry?
The pin is mentioned.
Let me see. If the pins are large, causing large holes, it will be difficult to draw an accurate line. Yeah. This is a key source error that cannot be avoided. Yeah, there you go. Yeah, show it to them. But it's not here. Strange. Yeah, because usually it's a very common thing. But I also agree with this one. I also like this one, placing the beaker back in its original position, right? So sometimes they say, like, those glass blocks, right? I think the glass blocks that you get in school is not like that one, right? It's not sharp edges one, right? Is it beveled? Usually say there's beveled. That means there's an extra facet here. Is it this sharp?
I want to use like that.
It's like this, this sharp. Oh, okay. Well, you can just say that the pencil is not infinitely thin, so when placing the glass block back, right, onto the paper, right, it may be slightly misaligned. Okay, right, the lines are not perfect. Then you see down here, imperfect circle drawn, right, and things like this. These are all okay, so you just choose one. How about for thermal? Key source error for thermal. Like just now that one there, the go and collect the cold brass weight mass and then put it into your beaker. What's the heat loss during transfer? It's a key source error you cannot avoid one, right? Even if you bring your water all the way down next to it, the moment you lift it and put it down, also still got some key source error. Which affects what? Well, actually, it's not okay. So it affects. Okay, so the idea is you have warm water and you have a cold piece of brass, right? So the idea is that there's heat loss to surroundings, right? Firstly you had warm water, right? Okay, you had heat loss to surroundings. Then when the brass put in already, when the temperature goes down, it might be colder than surroundings, right? Then it might be heat gain from surroundings. But those are all key sources error, so which you cannot avoid. Even if you have insulation, right, you will have heat loss and heat gains of surrounding, but you have to be very clear. When the water is warm, there may be heat loss of surroundings. During the transfer of the brass, there may be heat gain from the surroundings. And then when the water is cooled down already, there may be heat gain from surroundings. Yeah, below the surrounding temperature. Oh, painful. Okay, all right. But I'm still not done with this one yet. Suggested that n is the refractive index of water. State two conditions for this statement to be true. I mean, one very obvious thing to me is the glass, the thickness of the thickness of the beaker, right? The glass beaker, right? The glass beaker, right? That's an issue to me. So, what are the conditions for it to be true? I would say that the glass beaker would have to be very, very thin for the effect of the refraction due to the glass to be negligible. Yeah, very, very thin. And then I would say that the refraction through the glass is negligible. Yeah. And then I would say that, what else would I say? I'll say something. I'll say the temperature of the water is constant. Does that make sense? Temperature of the water is constant.
Can you say that? I mean, angel incident.
How does that affect?
Yeah.
Temperature? Temperature will change the density of the water, which will change the refractive index. Yeah, it does.
Can you say that incident, if it's not accurate, then it won't be true, right?
No, you can't say that. Because it's your job to make it accurate. So if your condition cannot be the actual thing that you're doing. I don't know. Maybe you're right. It just doesn't make sense to me though. But okay, let's see. Oh, it says cannot accept pins are too close. This is for Q though. This is for the conditions to be true. Oh, I would have wanted to say water not pure, but yeah, thin glass walls would have given me my mark. Okay, down here. So this is a bit stretching in. I would just say that the walls must be infinite, like very, very thin. Yeah, I will give 1 mark instead. Alright, come. Next one. What's this? So you place a letter R behind a beaker of water and it asks you to draw it. Well, I suppose yeah, you will look like that. Okay. So where you are? Oh yeah, okay. So you look like this. Okay. But then they want you to state the property of the image. Oh you. Huh? Laterally inverted. Upright, yes. It is upright. Laterally inverted, not opposite. Laterally inverted. What opposite? Opposite is the other side leh. Opposite is where the hawker center is. Bye. International school one, opposite. Alright, laterally inverted, upright. You have to decide whether is it real or virtual. Virtually real. Really virtual. No, you have to write it. If you don't write it, you get it wrong. You have to write the whole thing. Let me tell you, okay? This glass beaker acts like a magnifying glass. It acts like a magnifying glass. So it's like, yeah, but it's not laterally inverted, leh.
Yeah.
But that one does, right? Okay. It's virtual, anyway, it's virtual. Because you can't put it on the screen, right? This is the object itself. It's not that this is not the screen, this is the object itself. So you can't put another screen to go and capture this image. Yeah. You can't do that. So it's virtual. So now the question is it enlarged or same size?
But actually, why would it be?
Actually, you wouldn't know whether it's enlarged or the same size. It could be further beyond. What? It's not inverted. It's upright. It's upright. Laterally inverted. You won't know. You're supposed to put the piece of paper behind the beaker, see it already, then you say that it's laterally inverted. You're not supposed to predict. Guys, they ask you to draw the thing first, then ask you to describe the image. Yeah, exactly. There's one of those TikTok videos, right? They show you, oh, physics fun, and then they show you, and then put some arrow, right? No, they put the beaker there, empty, right? Then they put the paper at the back, then got one arrow pointing this way, right? Then you fill the water in, then the arrow point the other way. How do you do this? Yeah. No, seriously, how will you do this?
I mean, measure the circumference and circumference, which is like divided by 2.
Measure the diameter, then
Yeah.
radius.
No, but how do you measure the diameter?
No.
String.
How?
Circumference.
With a
Divided by 5.
Hey, I don't think that's very accurate. How are you going to make a string nicely in a circle like that? Hard like that.
You just use a ruler.
No, you can use a ruler. Yeah, but here's the problem. If you place a ruler anyhow, right? How sure you are?
Is it tangent?
Like how sure you are that that's the diameter? Like could it be here? Or maybe
That's
here?
obviously
Oh,
not
right.
tangent.
How do you tell?
Tangent, like put like 90 between the legs.
How? Come.
Tangent normal.
Huh?
You
Tangent normal?
do the normal.
A little bit back.
You draw a tangent.
Yeah.
Do you know that drawing a tangent is actually a very inaccurate thing to do?
Oh.
Yeah.
Never mind.
It's actually quite hard. So I'm in my mind I'm thinking about this.
Protractor.
No. That, what? You use a ruler, right? You take a few readings, then you choose the largest value.
Sure. Accurately though.
Yeah, because you know if you take many readings, right, as you move across, right, the largest reading will be the diameter. I mean that's what I'll do. That's what I'll do. That's what I'll do. I mean if you put a gun to my head and ask me, okay, go and I'll say, okay, take a ruler, right? Like you know, maybe another ruler. Make sure that the ruler slides across horizontally, right? And then the largest reading on the ruler will be the diameter. Then I will draw like a few lines to intersect and then get the center of circles. Strange question. Okay, let's see. The form. Oh, this is the actual thing.
Oh. Yeah.
What?
It's like diameter of the circle. I did this. But like it was.
Then why didn't you tell us the answer? What?
Like it was a container. Like you can do it like this way.
Oh, so two set squares. Two set squares and a ruler. Okay. And then that will give you the diameter of the thing, and then you. Also, you do it from another angle. You do it from another angle.
I can do it like this angle.
Huh? What?
You can do it like that. You just use a ruler.
Yeah, see?
Then you never suggest. Down here we all trying to rack our brains, and then down there you like, hey, yeah, I've done this before. Dude. Okay, submit your input. Oh, what? 2 marks for this? What's going on? Bonus marks? What's this? Why suddenly there's this extra 2 marks here? If you don't read instructions, get conned, is it or what? What's this A4? Oh, what you laughing at it? Also, this one, the beaker. So submit the beaker. That's for 2 marks. Can, right, that's fine. Electricity, what's the key source error? Electricity, key source error.
The wires heat up.
Yeah, so what are you supposed to do? Yeah, switch it off when not in use, right? Let it cool down before taking the next reading, right? Or wait for it to stabilize until you take the next reading. Yeah.
So keep producing.
Okay, so basically, you have what was that name?
Key source of error.
So when a circuit is left on for too long, the wires will heat up, right? And the resistance will increase and voltage and readings will change, right? So what you should do is you should switch it off whenever not in use. Yeah. Go.
Wait, why did I do the mark here? Okay. As a graph.
Yeah.
Where?
The table.
Like, oh. I don't know leh. I'm trying to look for needle and haystack and everything looks quite right to me there. Don't know. Can't tell.
Even the graph I lost the mark.
I mean, your Y scale is small. Your Y scale is small. That's why you love more. But the table, I don't know leh. Are your lines not clean?
Very, very,
Very petty mark.
yeah.
Don't know leh. Is it because your unbelievable temperatures? 31, 41, 51, 61, and 71.
Oh no, I made it like.
But my goodness, please do not use your pen to draw the crossings on. Don't use the pen. Please only use pencil. It's a habit thing. Explain whether component X obeys Ohm's law. And your answer says component X obeys Ohm's law. As the current and voltage increases, power increases. No, bro. Okay, you know, okay, I'm more confident of being able to tell you what you lost.
Yeah.
This one.
I forgot about it.
No. You're supposed to use the values of I and D measured. Means you're supposed to go and use these values of I and D measured.
Oh, and like.
And then calculate the resistance. Don't forget, Ohm's law, right? Means temperature is constant, but you're not measuring the temperature. So what's the other thing about Ohm's law? Resistance is constant also. Resistance is constant.
I take two.
So you're supposed to take, you're supposed to take a few sets, right? You're supposed to take like 3 sets. Take the V divided by I, 1 time, 2 time, 3 time, and then see whether the resistance is constant.
Okay.
Yeah. And then so that's why you lost 1 mark here. But you got the mark because we say Ohm's law, obey Ohm's law, but then the bottom part here is a bit strange, so that's wrong. Right?
Okay.
So Ohm's law is about whether or not the resistance is constant. That means the ratio of V to I.
Yeah.
I can't tell why you lost a mark for it. What is the teacher? What is that thing? What? Did any mark scheme for this? Oh, okay. Wait, see whether I can find another one. Whether any of these got paper 3. All don't have. All don't have. No, paper 3. PLMGS. Paper 3 prep. PLMGS reliable. Same question. Yeah, I checked wrong one. Paper 3. HF paper 3. Paper 3 marking also. All the things also. Let's see. Electrical circuit, motor. What's this?
Wait, so for calculation, do I follow the SF rule or like do I leave it as 3 SF?
I don't have an answer.
No.
I don't have an answer. Okay, let's set it down here and then tell you that the gunning thing guy made a mistake. It's supposed to be 2SF when your values are 2SF. Look at it, even the SGI side also. You see, 2.70 times 0.14, right? Correct or not? Yeah. Down here it says 2SF, right? Because why? Because the lowest SF that you have for the raw value is 0.14. So you have to use 2SF. Yeah. So just use 2SF. Just follow Lisa. So if you see that one of your values is 2SF, you just calculate 2SF. If you see both are 3SF, then you calculate 3SF. Right?
Then 3 and 2, then take the 2.
2, yeah. 3, 2, take 2. 4, 1, take 2.
4, 1, take 2.
Yeah. If it's 4SF and 1SF, well, there's no such thing as 4SF, to be honest. Right? Yeah, they won't give you let's say they give you 3SF and 1SF, right? Then you just take 2. Let's say it's 3SF and 1SF, right? You take 2. You don't take 3 because you can't do 1. So it's either 2 or 3, right? Yeah. Hey. 3SF or 1SF, right? Yeah. When you multiply these two, 3SF, 1SF, right? Your final answer is 2SF. Right. Yeah, because you can't do 1SF.
Even divide same thing, 2SF.
Yeah, yeah. And you can't do 3SF because 3SF too accurate.
What
so
did it with 1SF?
I don't know, maybe they say I don't know. Actually I also don't. Huh? Maybe temperature of ice 0.1. Huh? Hang on, I'm gonna print this one out for you. SGI.
What's a good score for practice?
What's that font again?
40.
40, is it?
20%.
Huh?
20%.
Yeah. It's quite high. Just now it used to be 15%. Yeah. Now it's 20%. Yeah. So that's why the more I see, right, the more I see A2 and A1 the difference is practical. Over the years, I've been noticing it's usually always just the practical to teach problems. Same thing for A levels. Like the difference between B and A, right, is really the practical. So you have to like really try to strive to get it right. It used to be 15%.
But does A level matter for university? Yes.
Which university are you talking about?
Like they look at A level score. It's like admission.
Yeah.
So you submit your A level score.
You submit your A level rank points. Why you suddenly want to do A level again?
No, I just don't know.
How does IB work? Yeah, yeah. A levels. A levels by rank points. So you get an A, you get like 20 points. Oh. Then there's a maximum rank point of like, I think your batch would not be the O1. O1 is maximum rank point 90. Right? Because 10 points is the project work, I believe. Yeah, it's damn lame thing. Then moving on, right? There's still project work, but it's not one of the subjects that you have to rely on. Like if your project work is good, you can use it in lieu of your H1. What?
It's like group work.
Yeah. Yeah. The worst politics come out. Yeah, like people hate JC because of project work. Yeah, like if anything, yeah, they hate their JC life. They hate their JC friends because of project work. It's like you think that you partner with someone who's like very honest and all nothing, right? Then afterwards you realize this guy doesn't turn up for any meeting.
Wait, you can't choose your friend.
You can sort of, I think, yeah, you can. Then the member will just poof, disappear. That's funny. Every year.
Scary, just like you don't want to go through everything.
No. Use answer key, man. Yeah. Always remember the answer key are designed. The answer keys are designed to help students in the O level. I know these are prelims. Okay? But they are meant to help students prepare for the. Hey, what else came out for your camp prep today? What was it again?
QA.
QA.
Yeah.
Got weird ones QA. Oh, my year got damn one weird one. My one, right? I still remember my QA, right? There was a faint white PPT that nobody saw. Only one person saw.
Yeah. Same.
Huh?
And then like thing going on with sulfate is
Hey, wait, how do you test for sulfate? Add barium nitrate, is it? Then you're supposed to get barium sulfate, which is the white PPT. So when you added it, what happens?
It was like colorless, but
then after a while, right?
After a while.
Yeah, after, right at the end, then when they collected my script, then I saw the white PPT and I was like,
That's the thing. You're supposed to shake it.
but there wasn't.
I thought the carbonate inside would react with the barium, and then that's why it's
Barium carbonate.
Wait, there was carbonate outside, right?
the carbonate
Wait,
is inside.
you had barium nitrate,
Yeah.
and if there was a carbonate,
There's carbonate.
Isn't they give you like random?
how do you know there's carbonate inside?
It's given.
So it's told you that it's an X carbonate, is it?
Yeah. No, there's like three. There's
Like 3 ions.
Copper carbonate.
and one
Wait, copper carbonate can dissolve in water?
No, never put water.
acid diluted nitric acid. Yeah.
There are 3 carbonates in that one sample.
No, there are 3
Oh.
ions.
There are 3 ions in that one sample.
One known,
One is a copper, one is carbonate,
and then there's one unknown.
one unknown.
Fluoride.
No, but
Yeah,
wait,
chloride.
but copper, how does a copper be in the solution is clear?
No. It's blue.
Yeah,
Blue
it's
with nothing.
It's like green because then you put
Yeah,
the
that's
nitric
right.
acid in.
No, but does it have any stuff inside or anything like that? Any insoluble?
Everything was soluble.
So the whole thing was a clear solution.
Yeah. That means
Clear
it's
blue
a soluble salt.
That means copper something that is soluble.
Yeah.
Like what? Copper nitrate? Copper chloride is soluble?
Yeah.
Okay. Copper chloride is soluble. What else? Copper nitrate can be also, right?
SL. Silver.
Cannot be copper hydroxide anyway. Cannot be copper carbonate as well.
Right.
Yeah, cannot be one. No, but then what's the carbonate attached to?
Nothing. It was just that carbonate is.
And then we gotta find that.
Because when heated.
Oh, it could be sodium carbonate, right? Yeah, because you there's no test of sodium anyway.
When heated, like the lime water turns white. Like a white, like the gas
As opposed to
involved.
carbonate.
Yeah.
No, but then that means that carbonate is unstable to heat. That carbonate is not stable
Right.
to
I
heat.
think you're overthinking this. We.
Okay, but then
Wouldn't there be a precipitate because there's.
Oh, so you're saying the third one is chloride, and the debate between chloride and sulfate.
Yeah, but she put iodine.
No, because when I saw
Alright.
the PPT, right, it had a little like yellow. Like if I compared my white PPT to my yellow PPT, it's a bit yellow. So I looked at it and then I compare again. Because Sally always tells me to compare, right? So I compare, but then it's that yellow. So I was like, okay,
But I saw white.
But
But what
majority
makes
put
it
white.
because
iodide?
Yellow.
No, as in
yellow
like, what makes it iodide?
the chlorine cell minus.
Huh?
No, because you get
Oh,
Silver nitrate.
Yeah, silver
You
nitrate.
added silver nitrate,
Yeah.
then you get silver iodide.
No, there's a difference. So if there's PPT is either white or yellow. White is chlorine, yellow is iodine.
Oh yeah. That's for chloride. That's for the
Chloride,
halides, right? That's for halides. Okay.
Wait, and then right,
Yeah,
there's
it's yellow.
No, but I wasn't sure about like one of the SM things. So like they asked like, cause we have to find the rate, then they asked us to round it up to 3SF, right? Then after that, so for the graph, I put 3SF for the rate. And then they said, what is the rate at this point, right?
1.7.
So I put 3SF for the final answer, but I don't know if it's supposed to be 3SF.
I put 5.5.
I put 5.
Huh?
5.00
Oh, okay.
for the rate, because they say 3SF.
I don't know whether it's a big thing.
And then
It is not.
BT.
And then I circled point of anomaly, but I don't think I'm supposed to.
Yeah, like BT. BT segment is so small. Sorry.
Is it compulsory to take chem? Like,
No,
Okay.
no. I have HR physics, SL math, but it depends on whether the school offers, because they have to arrange for the whole setup.
Wait, so if you circle it, then it's like the point they won't take that point into account.
Yeah lah, then don't.
But I circled it.
I don't
I
understand.
circled the point.
Did it? Wait, so
Yeah, but then if I circle that point, then there'll be only one point on the other side.
what? They say to circle the normal.
Yeah.
I don't know.
Is there an anomaly?
My graph like had like this point that is really far away from my best fit.
My graph was like pretty nice.
But now I realize like
Why is there that point then?
because that's the point they gave.
Huh?
Huh? Why is it they give you a point?
They gave
Point.
You all take the same practical?
because like they think plot from experiment 1 to 5, right?
You all take the same practical?
From 0, 0.
No.
No, we need to start from 0, 0.
Wait, the graph. Yeah, I did.
Oh, yeah.
Wait, your point must pass through 0, 0.
Yeah, for true.
Pass through.
Yeah, but.
I didn't. Oh my god.
Okay, read your graph.
No, they meant pass through origin as in like wait, they just say start from origin, but then I thought they meant like the graph like start from 0 and 0. But I didn't know the graph like you draw the graph from 0 and 0.
So what? That is so
Wait,
big.
so must pass through from 0, 0. But I didn't. Wait, how many marks was the graph?
5. You actively check the mark. No, I don't remember numbering. I don't remember.
Hey, how? I never passed through 0, 0.
Oh my god, okay. I'm just really good at like I have muscle memory. I can remember numbers really well. Then what was your percentage by math? 40.3. 40? What?
Oh, but mine, I think, cause like,
Wait, wait,
it
wait, wait.
wasn't 40.
What?
Mine didn't make sense.
What was 8?
No, that is the uncertainty thing, right?
Wait, huh? Is
No,
that
no, no.
the original? This is empty prep. This is empty prep. This is empty prep. This is the answer key. They
Wait,
look
if
the same.
you don't pass through from 0, 0, then your first is gone. The mark.
No, hang on. Your listen here. No, because this might be a physics thing also.
Yeah.
Listen up.
Whatever it's done, you can't change it.
It's not wrong.
Yeah.
But also at the same time, you have to remember this. Okay? If let's say you know that there's a relationship where y, x, you know that you know, in theory it's supposed to be y is proportional to x, for example. Okay, that's the theory of it, right? It's supposed to be proportional, but then your data points all over there. What do you do? Do you try to force your line of best fit through the origin because the relationship is that, or should you just draw it according to your data?
That's
What? Why is it saying what? Should you try to draw it according to your data, or should you try to force it across the origin?
But they, like,
I
if
would
they say
force it.
origin,
across.
if they say you've got to pass through origin,
No, they didn't say.
Oh, then just draw.
then according to the thing.
No, but they said that it's understood that the relationship is this, which means that the relationship should be directly proportional. Then when you plot your data points like this, and you realize that your line of best fit will not pass through the origin, so what do? Do you try to force it to pass through the origin, or should you just draw it based on your data points?
I would force it to be origin.
Force it through origin? Why?
Because they're already
Data takes precedence, you know. Yeah, data always takes precedence. I would draw to the side. I would just draw based on the data. Yeah.
But what if they say you have to pass through 0, 0?
If they say have to pass through 0, 0, then okay lah. Then you force it lah. You have to, right? They said. You know what I mean? Okay, so in this case, right? In this case, before you draw a line of best fit, you quickly go and read the back part of the graph. the back part of the question. Go and see whether or not they ask you comment on your data and the proposed relationship. You know what I mean? It's like you draw the data points, right? Then you draw the line of best. You realize that it doesn't pass through origin. But then they say the relationship is supposed to be this. Then they ask you to comment on the data as well as the relationship. Then you just say that the data doesn't it's not that doesn't show about relationship of the it's not true to the relationship, right? It doesn't it doesn't validate the relationship, or rather the relationship is not valid for the data. Okay, this is the very A-level thing for physics. Yeah, right? Because there's this thing called systematic errors, right? There's a consistent error in every one of your data points that causes the entire thing to push over to this side. That means whatever the value here is, right, there is something that's shifting it all, right? I have never seen them do this before, but of course we're always anticipating something weird happens, right? And this is one of those things that may happen. I don't know, never ever will it happen. I have no idea. But what I do understand is this. This can be easily caused by calibration errors. Let's say this thing here is supposed to be measure mass, okay? Let's say it's supposed to measure mass, okay? And then they go and tweak something, or they go and do something, right? That every single data point of your mass, right, is all shifted to the right side by a little bit. This causes the graph to all shift to the right side, right? And therefore it doesn't cut the origin, right? Then you have to declare that there is a constant error for every data point. Yeah.
How do you
Huh?
How do you declare?
You just say that lah. Whatever I just said, there's a constant error for
I
every.
just write it. Right.
Yeah. They will ask you to comment on the relationship, right? Then your comment will be the data doesn't validate, or rather the relationship is not valid based on the data. Based on the line, the best fit is not directly proportional, right? There seems to be a constant error for every data point, shifting the graph to the right.
Is it human? Oh, it's systematic.
This will be considered under systematic error, but I try to refrain from using that word because you're not taught those words yet. Systematic error, random errors.
Yeah.
Are you taught that? Yeah. Only you lah, but not the two of you. Yeah. Only some schools.
It's in the textbook.
I don't know.
Yeah. It's the first thing I learned last year.
Which textbook are you reading?
That one.
This one?
First thing I learned last
This one? Oh, see. Like, it's not even in the glossary though. Yeah, it's here. Shit.
It's there,
Oh my
right?
god, yeah. Shit, it's here. Oh. Random error and systematic errors.
Human as well.
But why is it here? Okay, there are really only two types of errors. Random error and systematic errors. Okay? Random error is human reaction error. Which means that it's completely random. Today you're a bit sleepy, you're a bit slow. Right? Tomorrow you drank 10 cups of coffee, your hands are very jittery. That's human reaction error. It's kind of like your thinking distance. Right? You see a red light, you press the brakes, right? From the time you see red light until you press the brakes, that's your thinking distance. Right? If you're very sleepy, you basically think for very long, then you suddenly press your brakes. Then thinking distance is very high. But it's a random thing. So yeah. Right, random error. Right, so that's random. Then the next thing you need to understand is the systematic error is a fixed amount of error, which is like zero error. Zero errors are fixed errors. Okay, so zero errors can be eliminated because you just need to know how much the zero error is, and you minus it off. That's eliminating the whole zero error. You understand this, right? Okay. Then you could also have okay, so human reaction error falls under random error. Calibration and zero errors fall under systematic errors. You understand this? Cannot?
Calibration error.
Yeah, what?
Calibration error.
Calibration errors and zero errors are systematic errors. Calibration errors. That means your machine is not calibrated correctly. Right? It gives a consistent wrong value to it. right? You want to take a picture, send it, and then send it to her or something. Random errors will be random things like human reaction error and environmental errors, and it could be like imperfections in the objects as well. Yeah. So those are all random errors. Okay, how do you get rid of systematic errors?
You do it 3 times and then find the average.
Right, do a few times and find the average. How do you get rid of random errors? You can't.
Yeah.
Because I mean, you want to get rid of human, is it? No, right? So you can't get rid of random errors. Sorry, I'm so sorry. My brain is not working. Okay, let me just repeat again. You can eliminate systematic errors by adjusting and recalibrating. That means systematic errors can be completely removed. Random errors cannot. Random errors can be reduced by taking average of repeated readings. Okay? Okay. Right. So I've given you another set of tracks to do.
Wait, you know for extrapolation, right? Do you extrapolate or do you not?
What is that? What does that mean?
But I feel like on time. Because I was going through like time-based graph with Jalin, then she said that physics also cannot extrapolate. Because I extrapolated, and she said cannot
What does that mean?
No, but why do you want to extrapolate? To do what? What are you trying to do? Find the y-intercept, is it?
Predict.
Why would any question ask you to predict? No lah, no questions will ask you to predict one lah. Yeah lah, no, we don't.
What is that? What does that mean?
Extrapolate means extend the line. Just extend the line the best way to another point.
But
Yeah.
like Sean,
Have you done it before?
yeah, my physics teacher, right, he told us to just draw the whole line. Just draw like out of the tape.
Draw out the page.
Just draw the full thing. That's what
We should draw the full thing.
So that's what
Because Jalin said don't, just draw a bit out, right?
Yeah, just draw a bit out of the final and first point.
Yeah.
Yeah,
So
don't
don't
do
draw
that. So don't draw it all out. Strange.
That's like
That's not what teacher said. Just draw the whole.
yeah.
No, I'm with Jalin though. Yeah.
Okay, so just draw a bit out.
Yeah, lor. Don't need draw
Yeah.
the whole thing. But I think very important is, guys, if your graph doesn't start from 0, 0, right, you cannot use the graph extrapolate to find the y-intercept. But if it does start from 0, 0, you can draw and go and use that to find the y-intercept. You understand what I'm saying? That's why I'm asking you, why are you extrapolating the graph for? If you're extrapolating it, that means you're drawing backwards, right? And your graph starts from 0, 0. You're trying to find no, as long as your x-axis start at 0. No, as long as your y-axis start at 0, right? Start from 0 up, right? Yeah, no matter actually it has to be 0, 0. That means if your graph doesn't start from a jump value, that means if your graph starts from 0, 0, and then your data points are like that, for example, right? Then you can draw a long one and then use that to find the y-intercept. You can.
So extend out.
Yeah, extend lah. You can do that. You mean Charlie said don't do that?
No.
No,
Yeah,
right?
it's here to do that.
What to do? What?
To do what?
Yeah.
Or just go past that thing.
If your graph starts from 0, 0. If it doesn't, right? Like for example,
Like
if it starts from like 5, 10, 50, 20, and this one here is a 4, 6, 8, 10, for example, right? Then you draw your line of best speed, right? Then don't go and cut the wax, because that wouldn't give you your 1%.
But
So
in
there's
which
no
case
need to
will
lah.
it start?
Which case will it start? But
Not.
no, yeah, it was no. There's sometimes some quite a lot of cases. What don't you have anything that doesn't start from? Let's say, for example, the length of this pendulum, right? Let's say length of a pendulum bob, right? Let's say you're starting from 1 meter, then 1 meter, 1.2, 1.3, 1.4, 1.6, 1.8. Correct or not?
Yeah.
Right? If let's say your length of the pendulum is, okay, let's say, okay, length is an independent variable, right? So it's supposed to be dependent variable. Let's say the time taken, okay, let's say the period. Let's say the period. Let's say your lowest period is already 1.2 seconds, and the next one is 1.4 seconds, 1.6 seconds. Let's say your data is 1.2, 1.4, 1.6. You wouldn't start from 0, because if you start from 0 here, then all your data points are like 1.2, 1.4, 1.6. You know what I mean? Then it's like all grouped up. Then your graph is very shortly. That's why you minus marks for your graph, because of the scale.
Yeah.
You should have started from a non-zero value. Yeah. Then you spread it out. So when you're trying to find a scale, right, guys, you find your y-axis, right? You're gonna find your max mean value first. Right? What's the minimum value? What's the maximum value? Then you see what's the you need to quickly decide what's the bottom value here. What's the bottom value here? What's the top value there?
Wait, and then let's say, right, you don't start your graph from 0, then you cannot draw that thingy, right?
Yeah, don't go and draw the
Then
zigzag
how
line.
do you
No, you just write the value down only.
You just flash.
Huh?
You just flash, right?
Slash.
Like people just flash.
Slash what? Really? Like that?
Yeah.
Oh, is that what they said? Oh, I mean, I would just write down the value here, 0.5,
you need to like extend it until it's like that.
1.5. What?
You need to extend it until it's like that. So like the 0 is here, and then the 0 is
No,
just
no, you just start from the base value there.
so you don't need to extend it out the x-axis.
No. Let's say it's like 2, 4, 6 like this, right?
Or just plot it.
Yeah, you just plot it right at the cross here.
Also, you're gonna draw a cross, right?
I mean, when you draw the two axes, they naturally make a cross, huh?
But then, like, don't you have like, cause like the graph paper, right? Don't you have to take like from right?
Oh yeah lah. I mean, the graph paper is like that, right? The grid square like this. Right, these are the grid squares, right?
Yeah.
Right. Then you draw your line from here and here. But I'm saying that the values start from here. Like
You can't like out of the thing. Like you can go out the way.
you can.
Like this thingy. Like you start from here.
That's what I'm trying to show you.
Mm.
Yeah, you can start from here. Like you draw your pencil marking here and here, right?
Mm.
Yeah, here and here. And you actually give a value here.
So they'll draw the cross, right? Like cross.
You don't have to draw the cross.
Oh.
Yeah. Why since when is that a thing? You just start from the value here. It's just that I would draw a little marking to indicate the value of the marking here. So 2, 4, 6, 8, 10, like that.
Oh.
Yeah, it's not that I have to draw a cross. It's not a thing to draw.
Oh.
You don't have to. But if you draw it, nobody cares.
Mm.
Yeah. Okay? Can? Okay, let's okay, I'm done here. Go through the practicals.
Uh-huh.
If you need more dry runs, you let me know. Yeah, let me know. But from now on, then you just focus on the dry runs. 20% is heavy, right? Are you not doing the MCQ for TY3? Right? Okay, a bit too simple, huh?
It's very repeated.
Yes, it is. It's very annoying. It's so annoying. Sorry, it's just like freaking annoying. see. I don't have much from here already. Have you? No. Have you? Yeah, I think so. Hillgrove, oh my god, that's my brother-in-law secondary school. The fuck happy? Okay. Cannot take care of it. Anyway, you just for practical also.
The STGS one is serious.
It's hard.
Yeah. A bit on.
Okay, I send it to you. You guys are the last surviving ones from that group. No one else will. Everyone else done their papers. Laura just got a result today.
Maybe they had a talk with the
72%.
teacher.
It was 72%.
It's a 6.
Huh?
Instead of 6, no?
Yeah. It's a 6. Not a
So
7.
the whole batch had a talk with
What?
the HODs.
Why?
Because a lot of them didn't do well.
Then tell them to tell the HOD to set a better paper. Then they
No,
will
no,
do better.
not the physics, like
Oh.
the math,
Math.
bio.
Same lah. Tell them to set better paper. What else?